Hello? Today I'm going to talk about AVL trees. AVL trees are a special type of tree that you would use in computer programming. It is a binary search tree. If you don't know what that is, then please look at one of our other videos. But there's one other condition that an AVL tree has. It has a balance property. What it means is that the tree must always be balanced at all times. That means the height of the left subtree and the height of the right subtree can only differ by at most 1. What does balance mean? For a tree to balance, the value has to be 1, 0, or -1. To calculate the balance of a tree, you would take the height of the tree on the left side and the height of the tree on the right side. That is, the height of the root's left branch and the height of the root's right branch. Here's an example. This tree, I show each node individually in the list here, and it tells you what the balance is of each node. Notice that the height of each node is 0, and except for 13, which is -1, because it took the height of the left tree, which is 0, and the height of the right tree, which is 1. So it said 0 times 1, 0 minus 1, which is -1. Now, what if we insert 16? Okay, so now we have to recalculate the balances of the nodes of the tree. And if we do that, we notice that the number 13 now has a balance of -2. That's bad. But I just told you -1, 0, and 1 are the only values we can have for the heights. If there's anything else that comes up, then this tree is unbalanced, and therefore it would not be an AVL tree. To make it an AVL tree again, we have to rebalance it. When you try to rebalance a tree after inserting something, there are 4 possible different situations. First, that you've inserted a new element into the left subtree of the left child, that you've inserted it into the right subtree of the right child, that you've inserted into the left subtree of the right child, or you've inserted into the right subtree of the left child. And for each one, if you have to rebalance the tree, then it's a little bit different for each one. For example, if you insert the left subtree of the left child, it would look like this. If you insert into the right subtree of the right child, it would look like this. Into the left subtree of the right child, it would look like this. And into the right subtree of the left child, it would look like that. And what I mean here is that the top one here would be unbalanced, and your new element that you just added would be down here. Now, when you have to rebalance an AVL tree, like I said, there are 4 different possible rotations that you can do in order to balance it. There's something called a left-left rotation, a right-right rotation, a left-right rotation, or a right-left rotation. This is what a left-left rotation will look like. If you insert a number, say 2, into this tree that we have here, you can see that we can do a left-left rotation because the we inserted the new element into the left-left side of the unbalanced node. And so, if we visually look at it as we rebalance it, this is what it will look like. You can see that the middle node became the parent of the other 2 nodes. We sort of just rearranged those 3 nodes. And now it's balanced. For a right rotation, if we insert a node like 8, then we insert the node into the right side of the node that's unbalanced now. So we can perform a right-right rotation, which is a mirror image of the left-left rotation. Good. Now the left-right rotation. If we insert the number 3, then we see that 4 is unbalanced, and we insert 3 in the left-right part of 4. And if we rebalance it, it would look like this. A right-left rotation, again, is the mirror image of a left-right rotation. It seems simple, especially if we're doing it all on paper with pictures. But you have to keep in mind exactly how you would code this, because it's a little more complicated if you do. Now you might wonder exactly which rotation you have to use at which given time. If the unbalanced node's height is positive, that is, the left side is larger, or negative. If it's positive, then you should use a left rotation or a left right rotation. Otherwise, if it's negative, then you would use a right left rotation or a right rotation. These are some hints of how you might be able to code it. Now here I have another example for you. We just inserted a new number here, 9, and now, way up high, the node at 5 is unbalanced. Well, we have to fix that. But we inserted it in the right space. So that's actually 3 ways down, not instead of 2. So what do we do then? Well, recall what I just told you. If using the hints I gave you, we could say that we should use a right rotation, because that's the side that's going to be unbalanced. That's causing the unbalance. So if we do that, it would look like this. Note that the node 6 is now the child of node 5 after this right rotation. So these are all different things you have to consider. Remember to always place the child of the correct parent after each rotation. The right rotation and the left rotation are considered to be a single rotation. That is, they deal with outside insertions, and they're generally simple. Right-left rotations and left-right rotations are considered to be double rotations, because they deal with inside insertions. Okay, that's about all I have to tell you today. You should think for yourself exactly how you might code this. It's not too difficult, you just have to think about how you would code each individual algorithm. It helps to create a method for each of the 4 rotations and call upon them when you think they are necessary. Good luck and thank you for watching.